an exponential word problem using the equation f of x is equal x to the n. This particular question is asking you to use your equation to find the instantaneous rate of change at a certain time. In this question, we'll be using prior knowledge from our grade 11 course and new material that we've just learned, such as logarithms. Okay, so our question has a part A, B, and C to it. The question states that the population of a town is decreasing at a rate of 1.8% annually. The current population of the town is 12,000. Part A says write an equation that models the population of the town. So that's our first step. And then after that, part B says estimate the instantaneous rate of change in the population 10 years from now. Part C says determine the instantaneous rate of change when the population is half of its current population. So part A, we're going to go back to what we did before in grade 11, and we're going to be using the equation f of x is equal x to the n to create our equation. Part B, estimate the instantaneous rate of change in the population 10 years from now. So when solving an exponential equation, your x value is the exponent, which is also the time value. And in this question, we are given the time value, which is 10 years. So we got to make sure to plug in the 10 years into our x value. Also with this question, make sure you don't mix up the instantaneous rate of change, or IROC, with AROC. If you do that, you're going to get completely different answers, and it just won't work. So make sure you're sticking with IROC. Finally, in question C, it says determine the instantaneous rate of change when the population is half of its current population. So if the population is half of its current population, we know the population. So we know that we're not trying to find that. Now what we're trying to find is we're trying to find the IROC at a certain time. And as you see in questions in part C, we don't have the time value. So that is what we're trying to solve for that. So now we know what we need for each part, and we have our prior knowledge. Now let's get to this question. You step by step now. The question says write an equation that models the population of a town. Now, from the information that we have before, we know that the population is decreasing at a rate of 1.8% annually. And so if you have 1.8%, you do 1.8 divided by 100, and it gives you 0.018. So because we need to put that number into a decimal so that we can use it in our equation. Now it also says that the population is decreasing. So what you want to do is you want to take your percentage, which is 1.8%, and subtract that from 1. So we can see we did that on the left side of the screen over here, and we got a value of 0.982. Also, we know that our current population is 12,000. So as you can see in the top right corner here, we have our original equation, f of x is equal x to the n. Now all we need to do is put what we know into this equation. So we have our x value, which in this case is 12,000, or our constant rate. And then we have our rate of change, or our rate of decrease, which was 1.8% annually, and then we put it into a decimal. So that is 0.982. So we have 12,000 times 0.982, all to the exponent of n. Now we don't know what n is yet because n is our time value, but this is our base equation that we're going to be using for the rest of the question. Okay, question B is stating for you to estimate the instantaneous rate of change in the population 10 years from now. So what that means is at 10 years, how many people will be leaving the town? So in relation to every single grade before that we've learned, IROC is equal to the slope of a line. So therefore, to find the IROC, we need to find the slope. And to find the slope, we need the equation y2 minus y1 over x2 minus x1. Now, we know that our base equation is f of x is equal to 12,000 times 0.982 to the n. That variable can be switched around. That can be equal to x. It's whatever variable you want it to be. Now, you know that finding the slope, you need 2 y values and 2 x values. And in this question, it's stating for us to find the IROC at 10 years. Now, with 10 years, if you just plug 10 as your variable, you're going to get 1 x value and 1 y value, and you won't be able to find the slope. So what you do in this instance is you take 10 and you subtract 0.001 from it, and you get 9.999, and that is going to be our x1. And then you take 10 and you add 0.001, and you get 10.001, which is going to be our x2 value. So now that we know that we need the slope, we have both of our x values that we're going to be using. All we need to do is plug those into our base equation, f of x is equal to 12,000 times 0.982 to the n, and find our y1 and y2 values, and then plug them into our equation to find the slope of the line at a certain point, or our IROC. So let's get started. So our calculations are over here on the right. So we start out with f of x is equal to 12,000 times 0.982 to the exponent 9.999. Now I plugged the 9.999 in there because that is our x1 value, as you can see to the left of the screen. So if you add all that up, when you do these calculations, first of all, make sure you're remembering BEDMAS. You want to do your exponent first. So you want to do 0.982 to the exponent 9.999. Once you get that value, you multiply that by 12,000. So our answer for this certain question, when we plugged our x value as 9.999 into the equation, we are left with an answer of 10,007.0026. Now, this 10,007.0026 is also equal to our y1 value, which we'll be plugging back into the equation over here. Next, we put our x2 value into the exact same equation. So you can see I did the same thing as I did up here, right down here, just with a different x value. So you do f of x is equal to 12,000 times 0.982 to the exponent 10.001. Remembering to do BEDMAS, you get an answer of 10,006.639. Now that gives you your y2 value. So now that we have our y2 value, our y1 value, and our x1 and x2 values, we can plug them into the equation y2 minus y1 over x2 minus x1. So you can see, as I did at that equation, I used our numbers that we calculated over here in our equations and plugged them into the equation of the slope of a line. So we have 10,006.639 subtract 10,007.0026. All of that is over our x2, which is 10.001, minus our x1, which is 9.999. So you subtract the numerator, you get one value, and then you subtract the denominator and you get another value. And then you divide the numerator by the denominator and you get your answer. In this case, our answer is negative 181.77. So back to the original question. The question was stating estimate the IROC in the population 10 years from now, or estimate the slope of the line at 10 years. Now, with every single application or word problem question, you need to finish your question or your solution with a sentence that relates back to your question. So here we have a negative value that we came out with our answer. So our negative value that's perfect. That's what you want. You want a negative value coming out of this because you know that your population is decreasing. If your answer is positive, that means your number is increasing and somewhere in your calculations you've gone wrong. So now that we have this negative number here. So we just put it into a word problem. I summed it up as saying at 10 years there will be approximately 182 people leaving the town, which is our final answer. Okay, now for question C. Question C says, determine the IROC when the population is half of the current population. Now our information that we have right now, we have our previous equation of f of x is equal to 12,000 times 0.982 to the n. Now, relating this back to the question says determine the IROC when the population is half of the current population. So we know what the current population is. It's half of the current population. Current population being our constant is 12,000. So half of that is 6,000. So that means we know our y value. So technically our equation should be set up as it is up here, which is 6,000 is equal to 12,000 times 0.982 to the n. Now, we don't know what our n value is. Now that's something new that no one has ever seen before in this question. So, but using our knowledge from the exponential and solving exponential and logarithmic functions unit, we know that y is equal x to the n. Now, if we don't know what our n value is, you can just simply log each side. Log is logarithm. There's the button on your calculator that says log. You would simply press that and then the number, and it would give you a value. So, if you have y is equal x to the n, you need to solve for n. What you do is you log both sides. Now, logging both sides, basically what it does is it brings down your exponent, so that allows you to solve for your exponent, which is in this case n. So if you have y is equal to x to the n, you can log both sides and it becomes log y is equal to n log x. And at that point you would just divide both sides by log x to isolate for the variable n. Now, all we need to do is apply what we just learned on the left side of the board to the right side of the board in our question. So let's repeat the question. Determine the IROC when the population is half of the current population. So now looking over onto the right side of the board, we have our equation. 6,000, which is half of the current population, is equal to 12,000 times 0.982 to the exponent n. Now, what I did from the first step down to the second step is I got rid of the 12,000. The 12,000 is an extra number we don't need, and it'll just make it so much harder to solve the equation. So what you need to do as your first step, once you have this equation, is divide both sides by 12,000. There. Now once you have that, you're left with 1 over 2 is equal to 0.982 to the exponent n. Now, as you remember from the left side of the board, we have y is equal x to the n. And to solve for our variable, we logged both sides and brought our exponent down. So, if you see that, you can basically see the exact same thing we did on the left side of the board using this equation right here. All it is just different numbers. So, from this step here, when we have 1 over 2 is equal to 0.982 to the n, all we do is log both sides and bring this exponent down. Once you do that, you have log of 1 over 2 is equal to n log of 0.982. Now, what you need to do is you need to isolate for the variable n, because that is going to give us our time period, because that's what we're trying to find. We're trying to find the time period. When is the population half of the current population? And then once we have our time period, we have to solve the IROC for that. So, we do log of 1 over 2 equals log is equal n log 0.982. So what you do is you divide both sides by log 0.982 to isolate for the variable n. Once you do that, you have your value. You have log 1 over 2 is equal to log 0.982 is equal to n. Now our final answer that n is equal to is 38.160555521. Now obviously you don't need to go to that many decimal places, but you should, just to be exact, before you get your final answer, because that, remember, n is not what our final answer is. What we're trying to do is find the IROC at n. N is our time value. So Now we have to find the IROC at n. Alright, so now that we have our n value, which is equal to 38.160555521, we can now plug that into our equation to find our IROC, our instantaneous rate of change. Now, as you remember from the previous question, finding the IROC at a certain time is the same thing as finding the slope of a line at a certain point. And as you recall, the slope is equal to y2 minus y1 over x2 minus x1. Once again, we can't just use our n value because that will give us one x value and one y value. So what we do again is we add 0.001 to our n value, which gives us our x1, and then we subtract 0.001 from our n value, which gives us our x2 right there. So once you have your x1 and x2 values, you simply plug them into the equations to find your y1 and y2 values, and then plug them back into the slope equation, y2 minus y1 over x2 minus x1, and that will give you your slope at that certain point at our n value. That'll give you the slope at the n value approximately, which will be our final answer. So you take your original equation, which is f of x is equal to 12,000 times 0.982, and instead of doing to the n, because we know our n value, we use our new values here, x1 and x2, and we plug those in. Now because these numbers are too long, x1, I just simply plugged in x1 to the top equation there. Now if you do f of x equal to 12,000 times 0.982 to the exponent x1, or to the exponent 38.161555521, you get your y1 value. Your y1 value in this case is 5,999.890877. So there we have our x1 and our y1 values. And then you have to do the same equation again, which is our base equation from question A, except with our x2 value. So in this case, our x2 value is 38.160555521. So down this bottom step here is f of x is equal to 12,000 times 0.982. Once again, x2, the number was too big, so I simply just plugged in x2. If you have your own piece of paper and you have enough space, you can just plug in the x2 value where I put in x2. So once you do that equation, 12,000 times 0.982 to the exponent of x2, you are left with an answer of 6,000.169355. And that gives you your y2 value. So now you have your y2, your y1, and your x2 and x1. So now you can simply plug your numbers into the equation to find the slope or IROC at when the population is half of the current population. So as you can see to the left side of the screen, that is where I did the calculation. You do your y2 value, which is 6,000.169355, minus your y1 value, which is 5,999.890877, over top of divided by 38.160555521, which is your x2 value, subtracted by 38.161555521, which is your x1 value. So once you subtract the top from each other and subtract the bottom from each other, you simply just divide and you get an answer of negative 108.985. Now once again, you want to make sure that your answer is a negative. If your answer is not a negative, that means that your population is in fact increasing, which is what we do not want. You want to make sure your population is decreasing at all times during this question, because that was the information we were given at the beginning. So now once again, we have our final answer of negative 108.985. So that means that our IROC is negative 108.985 when the population is half of the current population. Now finally, as I said previously, you want to make sure you end off every single word problem with a sentence summarizing what you just did and what your answer represents. So I concluded my question saying that when the population is half of the current population, there will be approximately 109 people leaving the town. Now this summarizes all the questions we had to take up so far for question 9 in page 508 of the Advanced Functions grade 12 textbook. And if you just want to know where you can use this in a real life scenario, you need it for many different things. If you're working for the government and or buildings or construction, anything that has to do with a certain amount of people coming in and out of a town. So if you're taking a consensus, if you're taking surveys, charts, anything to know the trends of a certain demographic area, that is when you're going to need this question. This question becomes very, very, very helpful in real life situations. Thank you for listening.